Hey folks, I'm Dave.
And I'm Ben.
And we shouldn't even need to say this anymore because you know who we are by this point, unless you've just started watching this video first, in which case that's a bad idea. You should go back to the first video and watch them all, unless you just want to know how for loops work, because that is the topic of the video today. Really, really important concept, and it's a little bit of a weird one to wrap your head around if you're new to programming, but it is definitely, I think it's fair to say, like with arrays, you know how when you learn how to use an array to set one up, just sparks start flying. You can think about things differently. Suddenly, how to make 50 things appear on screen is like, oh, I just use an array and I do this and do that, and it really levels you up, sort of thing. I think that for loops are one of those sort of level. If you understand how to write a for loop and to use it, I mean, this is the thing with them is that you'll think that you understand it, and then you'll see somebody's application of this concept, and it'll be, I can do that. And then you'll see nested for loops doing beautiful, awesome, complicated stuff. So there's always new stuff to learn, and I'm sure that if you're very, very experienced, this will all be going quite slow to you. But if you do not know what a for loop is, then you've come to the right place. Hopefully, at the end of this video, you'll be as confident as anybody with for loops, and you'll be screaming from your rooftops that you understand for loops. I wouldn't advise that either. Maybe scream it from downstairs in the safety of the ground floor. Okay.
Or just don't scream.
Don't scream it. Don't scream it unless you're on your own and you just fancy a good scream. Don't do it if it's late at night. Everyone's in bed. I understand. No, right. So moving on to the first little example.
A pointless tangent.
Yeah, well, I love the pointless tangents, Ben. I mean, thing is, most tangents have actually got a point, because otherwise, where are you going? You're moving in a direction no matter where you're going. You're always moving somewhere, Ben. Keep up. Okay, so what we've got here is a little project behind us in which we've got lots of commented out, so ignored sections of code. And in case you didn't know, actually, you can put these 2 forward slashes at the start of a line, and that will just tell Fuze to ignore everything on this line. So Ben writes print, and then he puts 2 slashes. It goes grey to signify it's not going to listen to that anymore. If you want to comment out a whole chunk of code, then you can use that technique that you can see on screen now, which is the forward slash and the asterisk. And then you close that with the reverse, which is just asterisk forward slash. And you can use that on either side of the big block of code to just remove it, rather than cutting and pasting it and get rid of it. Comments are really, really helpful, and you can use them to write all sorts of instructions and handy hints in your program. And I do recommend that you do that, because if you come to a program like 2 months after making it and you haven't written any comments and you've used really weird variable names, it can be quite a slog to refamiliarize yourself with your thought processes from the past. But it's something we have to all deal with, and you do learn.
Yeah, and I just wanted to mention this structure that I discovered.
Oh yes, it's a lovely technique, Ben. Yeah, take all the credit. I actually now use this, so I have to admit it's very nice. So you've got a commented block of code there, Ben. Yeah.
Yeah.
Okay, so that's a multi-line comment. So what are you going to show me here? Oh, that's genius. Look at that. Now you can, of course, just delete the asterisk forward slash or the forward slash asterisk. Thing is that's actually really annoying to type it again.
Yeah.
It's way easier to just type forward slash either on the keyboard or with the Joy-Con input, because you just hit the same button twice, and that tends to be a lot easier. In fact, when I saw this, I was just, that's genius. And now I do that all the time, all over the place.
And also, you only have to do it once; you don't have to do it at the end as well.
Oh yeah, I didn't even realise that I was doing it on both always. I'm a little bit slow, okay? You forgive me, but
you learn something new every day.
You do. Or if it's in my case, you learn about 28 new things every minute, and you can't remember them all, and you just sort of hope to hold on to some of that knowledge by the end of the day, if you're lucky. Right, so we've got lots of different examples here of what we call for loops, and we are going to go through, explain each one, and it just kind of shows different applications for this concept that you can use all over the place. But first, what a for loop actually is, it's actually quite simple to explain. It just looks weird, and the name for loop is weird. The reason it's called for a for loop is because of the old sort of syntax used to set these loops up. They used to be called for next loops because you'd use the word next at the end. You'd say like next I or next J or whatever your counter is.
Didn't know that.
Essentially, it is just a loop that goes over, it iterates a certain number of times. So you can tell it how many times you want this loop to repeat, and you might, that might be all you need to do. You might just want 10 things to happen before you move on to the next thing. But the cool thing about them is that they define a variable, a local variable, which means you can reuse this variable all over the place in your program as long as you're not reusing it in the same, loop or in the next loop. And I don't want to get too hung up on that there, but it defines a variable which is used as a counter during this loop. So let's just take a look at this syntax. This is pretty much the easiest and simplest for loop to wrap our heads around. So we've got for I equals 0 to 10 loop. And that just means create a variable called I, it's equal to 0, and then I want this to count up in steps of 1 until we get to 10. Now, Fuze does something here. I don't want to get this fact wrong, but Fuze does something here that is the same as in some languages, but different to other languages. And lots of coding languages do this slightly differently. There's a reason why it behaves in the way that we've decided to make it behave, and we'll see that at the end of the video when we start to use this with an array. But when you write for I equals 0 to 10, this variable I is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 9. And it will never actually reach 10. It counts up to, but not including, the final number. And the reason that we do this, we'll go into more detail at the end of the video. But for now, you just need to know that. Now, it's interesting because when you write for I equals 0 to 10, that is 10 iterations.
Yeah, I was just
which is another reason why we did this, is to make it easy to just understand, I want this to go 10 times, so 0 to 10. You want it to be 0, it's going to go over 10 times. If you wanted it to go and actually include the number 10, you would have to put 11. Or you could just put 10 plus 1, but obviously you're not going to do that. You're just going to write 11. But it's a nice way, to remember what that upper limit is, and then you can just add a 1 or add a 2 or add whatever you want to it. So this variable I, as soon as we reach this word repeat, we go back to the start of our for loop, except now I is equal to 1. And then on the next time round, I is equal to 2, I is equal to 3, etc., 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 until it's done. And then when I is 9, and it doesn't get over to 10, so when that condition is completed, we then move on past the repeat line. So in this case, we're doing 10 update commands with 10 different print statements, and then we're doing one sleep command for 2 seconds. So we're going to see 10 numbers on the screen. Hopefully, we should see 0 to 9, and we should see them for 2 seconds. Let's just run the program and see if that's what we get. Right, there we go. 0, 1, 2, 3, blah, blah, blah. Now, they haven't got any spaces in. We could add a space to this very, very easily. Just do a comma and then speech mark, space, speech mark, and we've got spaces between the numbers. Hopefully, you can see that okay up there. These are taken from the Fuze for Loops tutorial project, which is inside the Fuze help. Yeah, you might as well just get a quick text size command in there then. 101, text size 101 with Dave. That's going to be a mainstay now. I really like that. So yeah, that's the easiest sort of for loop to imagine here. Now we can change a bunch of stuff here. We don't have to start at 0. We could start at 5. We could start at 9. We could, obviously, if we started at 9, then we would want to increase the upper limit. Otherwise, we're not going to get any numbers. Well, we'd just get 1. We'd just get 9. So from 5 to 14, and we're printing from 5 up to 13. Remember, up to, but not including that final number. There's also another addition that we can make to this, well, yeah, let's just introduce it here, and then we can show an example of it being used in a more interesting way. You don't have to count up in ones. If you write the word step, you can provide any step count to move up or down in, because you don't even have to go from 5 to 14. You can go from 14 to 5. You can move in steps of -2. You can move in steps of 5.384. It's completely up to you. You might have to do tons of different stuff and any number of different iterations of this to get what you want out of your program. And in fact, if you take a look at the Fuse demo programs, as always, it's a good place to go when you learn something new in these videos. Take a look at the Fuse demo programs and spot where you see these techniques. If you go through and you see, there's a for loop, you now know what it's doing. Well, hopefully by the end of the video, you will be much more comfortable with what it's doing. So there you go. We're printing a number. That's it. Shall we move on to the next example then?
Yep.
Okay.
So just down here.
Just down here. Stick the 2 comment lines in there. That's brilliant. Now, this one actually does use some audio, but I'm not sure if your sound settings are going to be quite quiet there.
It was all right when I tested it.
Did you test it earlier on and it was okay?
Yeah.
Okay, let's give it a go. So actually, before we run this, we're using the play notes command here, and also a sleep within the for loop. Now, if you're writing a game or anything that's doing something that needs to be fast flowing and smooth, you won't want to do this. You will not want to use a sleep in a for loop, because remember, if you've got a for loop within another loop, like an infinite loop, and then you've got a for loop to, I don't know, draw all of your characters in a scene. If you have a sleep in there, that's going to be sleeping for every single thing that it does. So it might ruin your program. But for these examples, we're just using sleep so that we have a nicer sort of little demonstration, basically. This uses the play note command to play a frequency. And in the frequency counter up here, our frequency that we're playing is I. So yeah, channel, wave type, frequency. So I think one is a sine wave, I believe, or a saw wave. So this is going to be a saw waveform, playing every frequency from 0 up to 900 in a step of 5 hertz each time. So it might be quite a weird one. Have you already tested this, Ben? It should be like a rising sort of thing. I mean, I'm not maybe not sounding like that. Can't do a perfect saw wave with my vocal cords. Let's give it a go. It's very, very quiet. Ooh, nice. Now, I hope that you can hear that all right. I might just, if you come out of that then, and let's just up the volume a tad. That's wave type, that's volume, isn't it? If we make that like 8. So hopefully you can hear that a bit better. We've got this sort of rising pitch. Now you could use something like that in a game for like an alarm sound or something like that. Or, I mean, there's tons of different applications for this. Or you could do it the other way around, going from 900 to 0, and you could stop. That's getting a bit high pitched. I think might be grating on some people. But you could use that maybe for like a falling off a cliff sort of sound. There's tons of different applications for that sort of thing. Okay, so that is using it with play note. Should we move on to the next example? Yeah, so using it to draw. This is one that's used quite a lot. This one, if you take a look at that initial line, we're not using I. In fact, actually, I should have maybe spoken about that. I've missed it out. It's something that when I first saw for loops, and I was trying to learn, I mean, this is a few years ago now, I found it really weird. I was like, why are we using the word for? Why are we using, like, why is it I? What does I mean? And for I is this, for J is this, what is this? It doesn't really matter what you use. We tend to just use a small, single letter variable because you're going to use it all over the place in the for loop, and it's local to that loop or if statement. To that for loop, so you don't, have to worry about reusing it. So it's not really a problem. It's bad to, well, not bad, but it's not really conventional to make global variables with like one letter name. You tend to use those in for loops locally. But usually we use whatever letter best signifies or represents the thing that we're using it for.
Well, I is most conventional, I think, really.
Yeah, it's all over the place, that is. I mean, and do you know what it's short for in this instance?
I would guess iteration, but don't quote me on that.
Actually, that would work, eh? I like that. I've always thought it was index, because you're so often using it as an index into an array that it's like this index, that index, this current index. But yeah, iteration as well. They're both really good.
Yeah.
But it's like, so then why J? Jindex? Don't know.
Jitteration.
Jitterations. Yeah, so in this case, we're using
Comes
it.
after J.
Yeah, it comes after J. That's why it's used. But it's just that, it's just funny that we have one that makes sense with I and index, and then J. Well, why not? So, but in this example, we're using it as an x coordinate. So we're going from from 0 to g width in steps of 1, because if you don't put a step in the loop, it's just a step of 1. So we're going from 0 to g width, every single pixel along the x-axis, and we're just going to draw a 1 pixel box. So we're drawing this box in the middle of the y-axis, that's g height divided by 2. The 1 is the width, and I believe the
10 is height.
10 is height.
Changed it. So
You changed it so it's actually visible. Then
Yeah.
thank you. It's not a 1 pixel box, it's a 1 pixel wide, but
Yeah.
10 pixels high sort of line. And this is being drawn, and it should be sort of just going past, I imagine, well past Ben's head by now. It's sort of. I wonder how this will look. Do you reckon it's above us? I was hoping it was like going through our ears or something. You could do some weird expression as it came in. So this is a way to just.
Yeah, can't you see it up there?
Oh yeah, sorry, completely. Well, it's white, isn't it? And there's a white ceiling, so it's hard to see from here. So daft. Hopefully, you understand what's going on there. We're using the exact same technique. It's just an iteration, keeps going. The upper limit is just the width of the screen, and we happen to be using this variable, this x variable, in the x position of a box function. I found that very, very hard to say.
We're using a variable in a function.
We're using the increasing variable counter in this function. Now, of course, it doesn't matter what you call a variable, or what you define it as. It is just how you use it that actually counts. That's where the important bit is. We could call this for. I think my brain has just switched off. I don't have any great examples. Maybe I need 3 more cups of coffee. For coffee, I knew it was going to be. So, you could call your variable whatever you want. It doesn't matter. It's still going to behave the same way. But get into the habit of naming your variables as things that make sense, things that make it easy for other people to actually read your code as well. Because then when you share your project, people can have a better time and a more fun time changing things around and seeing what they can make happen. So let's go to the next example. We're going to have to comment that one out. So that's using a for loop to draw a single line. And what have we got here then? Oh, that's the same example, but with a big step. Oh, and you've also got something going on there as well for y equals 0 to g height. I'm intrigued by this one then. You've modified the example in the tutorial. So we've got 2 for loops happening here. One of them just did a series of small, thin boxes, just like the ones from before, going across the screen in steps of 100 pixels at a time. And then the second for loop is still going, actually. It's going to finish in a second. And it's just drawing a circle at a random position on the x-axis. And then it moves down by 1 pixel. And that is the y equals 0 to g height part. So we're going down the y-axis by 1 pixel at a time with a random x position circle at every single pixel down the y-axis. Got that one right, okay? I think that all made sense. And you can see that the result of that is just quite crazy. And I wrote this demo just so you could see sort of a for loop in action. You're sort of seeing, even though it's quite hard to make out which circles are appearing, maybe if they sort of faded out or they cleared the screen between each one, it'd be more apparent.
Yeah, we could do that.
But because we could just put a clear. So it draws those first, and then tell you what, Ben, if you put if you do false in the outline portion, in the outline parameter of the circle function, then this will be a bit more visible to the viewers, I think. So do false, we get the boxes, and then So we're now clearing the screen between each circle. So there's only ever one circle being drawn, and
hit us on the head.
It's about to. It's going to be. Okay, this is going to look so silly and cringy when we watch it, but hey, that's fine. I'm fine with that. I'm used to making a fool out of myself in front of large numbers of people. So hey, nothing new there. So we are finished with that example, I think. Shall we take a look at the next one? This is a really important example, and I'm quite eager to get to this one. So for loops are used all over the place and for lots of different things, but
for lots of different things.
For lots of different things. But one application, it was a little bit, wasn't it? A little bit. Never mind. Give up. I've give up. Couldn't think of a pun fast enough. one way in which for loops are used all the time, and I would say probably the most important application of using for loops. This is, as soon as you get your head around this, you'll be doing it all over the place in all of your programs. Using a for loop to iterate over an array of data, and then using the variable that counts up in the for loop as an index into that array. So you might use this to draw all of the enemies that you are preparing in your big array of enemy data. Or you might use it to draw all of the tiles that you've got in the design of a level in a big array. Or you might use it for something really basic like this, which is just an array of names. Dave, Kat, Ben, Luke, and John, the members of the FUZE team that are currently in this office right now. And
Charlie.
we're just... Oh, and Charlie. Oh, I forgot Charlie. Ben, do you want to add Charlie to that list? Yes, in the position that he actually occupies. Absolute top dog. Oh yeah, we need a comment after that because we're separating out the elements. And now we're missing John at the end here, actually. Because we are only going up 0 to 5. So if we just change that to a 6, then we're getting the right elements. We could also change that to len names, so the length of the array. In fact, we should, because this is the main reason that we made for loops count up to but not including that last number, because of this application. So let's just cover that line 73 here, because that is a little bit strange looking. And in fact, I just want to change these I to 0 here. So that's a little bit simpler. So we've got our array of names. Simple as. We've got names 0, names 1, names 2, names 3. Of course, I'm going to say again, if you haven't watched the video on the array tutorials, then I would strongly recommend that you do that. And then come back to this video, and then you'll exactly understand what we're doing here. So we've got these 5, 6 names, and they exist in the elements 0 to 5 in our array. So you've got names 0, names 1, names 2, names 3. Now, even though there are 6 elements in this array, 0, 1, 2, 3, 4, and 5, but the last element is 5. So with the way that for loops work in FUZE, when they count up to but not including the value that you've stated, if you write for I equals 0 to len and then the name of an array, so our array is called names, we're just saying I equals 0 to len names.
This will... talked about len?
I think we did cover this. I think we did mention it in arrays, but len is it's a nice and simple one. In case you don't know, yeah, just the length of an array. So it just gives you how many elements there are.
So 6 in this case.
This is 6. So even though the last element is 5, the len of the array is 6. And in this way, I could now add, or Ben could now add, any amount of elements to this. And each one will appear in our list. If you want to add a couple more names, Ben. So len is really, really useful. Use it as much as you can. If you've got an array that you want to keep changing and adding things to, then whenever you use that array, you want to use len so that you're not having to keep changing the numbers in your for loops. I'll do. And that will appear as well because we're using len. So just to reiterate, okay? Just to go over that again. The len of the array is now 7 because we've added that last entry. It's 7. So this for loop really says for I equals 0 to 7. Now, if it got to 7, then it's going to take the number 7 and try and use that in the array. And of course, that will not work because the last element is 6. 0 to 6 for a total of 7 elements. And this is the line which is actually making that happen. So how we fetch the text, where we're actually getting it from, is in that line there, 74. I don't know why I'm pointing over here, that line there, 74. And it's the name of the array. And then in the square brackets, we just index the array with the I variable counter. And you will see this all over the place in the FUZE demo programs. I would actually go through, and now that you know this, see how many times you can find a for loop that uses the array, that uses the index to reference an array and to go and get information from the array. It's all over the place. In fact, I think it's one of those mandatory things that you have to learn. As soon as you want to, make anything of not importance, I don't want to say that, because some games are fantastic and they do so much with so little. Pong is a great example of that. You don't need any
Yeah.
for loops or any arrays in Pong. It's just beautifully simple, doesn't need anything else. And indeed, you might have tons of game ideas that do not need these techniques. And just because they don't need those techniques doesn't make them any worse. In fact, in many ways, it makes them a bit better because it's, beauty and simplicity and all of that. But as soon as you want to do a few different things, like you want lots of things on screen and they're all being calculated, you want to collide against a ton of different things, you will need this technique. You will need a for loop that counts over an array using the variable counter as an index into that array. There's also another place that we're using the index as well, the I variable counter, which is, as you can see in the printout line, as the Y position of the names. So the first one is 0, that's print at 0, 0. And then I is 1, which means we move down by 1 row. Then I is 2, we move down by 1 row. And it goes down, printing all of the names. So hopefully that is a nice introduction to for loops that has given you a bit of a head start in using these concepts in your own programs. Now, I would recommend writing your own for loops for yourself. This is one thing where you might not necessarily wrap your head around it just by hearing it said. You kind of have to write them out.
Yeah.
Make mistakes, give it a try, and then you learn a lot from those mistakes. There is, of course, also another edition of this, or another addition to this, where things get a little bit more complicated. Now, I remember explaining this concept to somebody who we had at the office once. And for loops, no problem. I'm explaining for loops. Yep, I've got that. No worries, Dave. For loops? Yeah, I know for loops. Okay, so then if we put this for loop inside another for loop, and then he was like, "You've lost me." That's it. I always remember that. It was really cool. I always find that when you put loops inside of loops, this is where things get a little bit strange. But I just want to show you that it's possible and the syntax of how that would look, because it's important that you know that you can do this if you weren't aware. However, we're not going to do a large-scale example of actually using this. I just want you to see what it looks like. So first of all, we'll just comment this out here. No, we won't. I'll go up to where it actually should be, and we'll bring this. There we go. Okay. So I'm just going to get rid of the keyboard here so you can see. We might have something like this for... I'm going to call it outside equals 0 to 10. And then I'm going to put my repeat in there. I actually have this habit of always putting the repeat in before I do anything else because I always forget. Do you? Yeah. Oh, no way. It's a really helpful one. And then inside that for loop, so this for loop right now, pardon me, this for loop right now, let's just reiterate, is going to go over 10 times outside equals 0, outside equals 1, outside equals 2. And then if we put another for loop inside that, and we can call that for inside equals 0 to 5 loop, and put something in here, what we have here is a loop that's going to go over 50 times. This instruction in here will happen 50 times. And it will happen 5 times for each of the iterations of the outside loop. You can imagine this as a circle inside another circle. So we're going round one circle. And when we get round, we're going to go inside the little circle 5 times. And when we're done with that, we move around the big circle again. That's sort of an idea. This is called a nested loop. And you will need to use this in a ton of different situations. But what are you going to do? And I'm intrigued. Yes, that's a good idea. In fact, let's print inside, then let's put a few spaces, and then let's print outside. I cannot type, apparently. And then I guess we want to update that. In fact, we probably want to clear. We'll sleep for 0.5 seconds. Let's see what this looks like. So as you can see, this counter on the outside will get to 10. Beg your pardon. Did I print inside first?
Yeah.
That counter over there will get to 5. In fact, I don't want to do it that way. I want to print outside, inside. I didn't get that right the first time. Let's go outside and then inside. So what we should see is the counter on the inside, so this one, will get to 5 before that next one moves up by 1. When that one on the left, the 3 right now, gets to 9, we'll be finished. So it's a loop that goes around inside another loop. And this is used to mainly go over 2-dimensional arrays. if you've got something where you've got, for example, rows and columns. So a good example of this is in the game tutorial, where we use this exact technique to build a level and draw a level using a big array of tile data. So I've got a big array that is actually an array of arrays. So it's like 3 or 5 rows, and each of those rows has got 10 columns. And so you want to go row 1, column, 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 row 2, column, 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 and then you move down and it goes over each element and you'll cover everything this way. So don't worry if that was a lot of information. For loops.
We have got another example.
Have we got another example?
Yeah.
Oh yeah, Ben, you did an awesome little demo example beforehand. Yeah, let's go into that. I was going to wrap up, but no.
Absolutely not.
Yes, of course, this is our Deluxe Edition Super Elder Powerful Strong Cool Strong. There's 2 strongs. Powerful Strong Cool Strong Adder Machine of Glory version 8.53 Platinum Edition Prime Plus, aka the DES EP SCS AMG V8.53 PEP Plus. That is patent pending, by the way. I think I did quite well there. I love that you've got 2 strongs. That is very, very silly indeed. So this is a nice little example of like an addition machine. And there's nothing here that we haven't
Don't you
looked at
mean
before.
a deluxe edition Super
I
Elder
beg your
Powerful
pardon,
Strong
yeah, of
Cool
course.
Strong Adder Machine of Glory version 8.35 Platinum Edition Prime Plus.
8.35. That was ages ago, mate. This is 8.53.
Oh yeah, sorry.
Whew.
Did I get it mixed up?
You did indeed, with the old version. That old version was terrible. So glad we made the change to 0.53. Let's go through this project here, Ben. What have you got?
Version 4.
What's going on? Tell us what's going on in this program, Ben.
Okay, so we've got an array with
Yep.
a load of different numbers.
Just random numbers.
Are they random?
I think so. Are they not?
Maybe.
Okay. We'll go with random. Randomly selected by Ben.
And then we've got sum, which starts off as 0.
Okay, so this is going to be the sum of all the numbers that we're adding together.
The result.
Yeah.
And then for everything inside the array.
Yes.
So I can find it.
So you've used that 0 to len nums, that exact technique we just went over. So the length of the array, which I don't know what that is. But it's 1, 2, 3, 4, 5. I'm not going to count all those.
20, I think.
Really? Right, I'm counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's 20, Ben. How did you know that? It's almost like you wrote the program beforehand. Or the numbers aren't random at all. If you know... Okay, Ben, don't tell me. If you know what those numbers are, and you know what Ben's talking about here, then leave a comment and enlighten me, because I've got no idea. That's all. But I would rather be surprised by you guys than by Ben. So what's our for loop doing?
Okay, so for every iteration, it's going to take a different number. It's going to take the next number along.
Yep.
And it's just going to add it to
our sum.
The sum variable.
Nice and easy.
And then change the text size and print it and not update it.
Oh yeah, nicely spotted actually. I didn't see that one. Common mistake.
I'm sure that was working.
Yeah, that is odd if it was working. So let's give this a go. So we should
Dave,
just
what does that add up to?
Oh, that obviously adds up to 86. It's not 86.
No.
I'm out of ideas. Exactly 100. Very nice.
That's what I meant about it not being completely random.
I see. Gosh. I'm going to tell you, Ben, I feel very humiliated and very silly. I should have seen that coming a mile off. No. Who's going to guess that? No one can do maths that fast. I say that now, but lots of people can and do regularly. So that's really nice. You've got this little addition, little program here. Beautiful, nice and simple use of the for loop there, the Deluxe Edition, Super Powerful, Strong, Cool, Strong Adder Machine of Glory version 8.53 Platinum Edition Prime Plus. And it's a really nice example, Ben. Thank you very much.
That's all right, Dave.
Right, let's see some examples of you guys using for loops in your programs. Just whatever you want. I just want to know that you guys are understanding it. Check out all the FUZE programs, all the FUZE demo programs, and spot the amount of times that for loops are used. It's probably going to be in every single demo. It's that often used a technique. It's really, really useful. I urge you to try this out for yourself. Just start writing for loops and see what you can make happen. Experiment. That is always what leads to the most learning. And hope that you've had fun watching this video. I have been Dave.
And I have been Ben.
As usual. And well, before we go, what are we going to look at next? Because I think this is actually quite exciting now, because we have now covered, I think, all the concepts that I wanted to cover, or that we agreed we should cover, before we move on to something a bit more substantial. So we've done loops, we've done variables, done if statements, done the controls, done the screen, done arrays. We've done what we've just done, which is for loops. We've touched on like multi-dimensional arrays. The only thing we haven't touched is structures.
Structures and while loops.
Oh, while loops as well. So let's make that a next video.
Yep, okay.
I think if we take a look at structures next, which is a much more advanced form of storing data, and this is one of those cool things where it looks really, really cool and complicated. So if someone sees that you've used a structure, they're like, wow, this guy knows what he's doing, or knows what they're doing. But it's really easy. It actually makes things so laughably easy. I thought, like, when I learned about structures, it actually made me, I don't know, it was like why don't we do this all the time? Just naming stuff.
It does make you feel smart.
It does. It really does. So look forward to that. In the meantime, check out FUZE Arena. I'd love to hear from you guys, and take care.